Hi guys, welcome back to my YouTube math channel. So today we are going to try to prove trig identities. We are going to verify trig identities. So far we have covered a lot of basic trig identities and basic things that we need in order to actually come to this point where now we are going to actually use all that information to verify or prove more advanced trig identities or trig formulas. Guys, before you start watching these videos, please do me a big favor. Please grab the formula sheet for the trig identities and have it in front of you. Okay. So once you have that in front of you, then you should start looking at these videos, because we will be pulling in a lot of the formulas, a lot of these identities from the formula sheet. Again, I remember a lot of these things. Again, I don't remember all of them, but I remember a lot of these, so I will be able to use them from my memory. But if you are not confident with those, or you don't remember everything, guys, that is totally fine. Just have the formula sheet ready in front of you, or like whether you are using a textbook, have the textbook in front of you, or I would say everybody should actually have a formula sheet. Okay, so without wasting any further time, I'm going to start proving this identity. I already have number one here. I'm going to probably do 7 examples, which will cover like a broad spectrum of these identities, involving the sum, the difference, the basic Pythagorean identities, even the basic identities of tan in terms of sine, cosine, so on and so forth. And we also did the double angle. There's the half angles. There's so many of them. So we'll probably look at many different variety of examples in this proving trig identities section. Okay, so guys, let us focus on this particular example right here. Once you have your formula sheet in or formula somewhere, let us look at this particular example. So guys, the whole idea of proving any identity is like we want to either work with one of the sides and make it like do simplification and see that if it actually looks like the other side, or sometimes we may have to work with both the sides and make them look alike. Okay, guys, each problem is different in its own aspect. Now, if I look at this one, I look at the left hand side and the right hand side. Obviously, if I look at the right hand side, it looks to me that right hand side is already in a simpler form, right? There's only a cosine x. So what does that mean in terms of like simplifying here? It means that we should not try to work with the right hand side. Rather, it seems like there's more stuff going on the left hand side. So it makes sense to actually start with the left hand side. Do the simplification process, use the identities as many as we can, or we can see from the formula sheet, and then see if we can finally simplify this and make this look like the cosine x. So that's how you usually approach these type of problems. Okay, here we are going to start with the left hand side and then see if the left hand side simplifies to the right hand side. So I'm going to start with the left hand side, and we know why we are starting with the left hand side now. So guys, this is my left hand side, right? So in order to simplify this, guys, there's few different ways. There's probably going to be few ways to simplify things. If you have a different way of simplifying, that is totally fine, but I'm going to show you like one of the ways of simplifying this. So what I'm going to do here is, because back in my mind, I know that I want a cosine x. So what I'm going to do first is I have a secant x, and I know that the secant x is the reciprocal of the cosine x, which you can also see from the formula sheet, or that is something very basic. So that is something you already know. So what we can do here is secant x can be written as 1 over cosine x, right? And then I have minus, well, sine x, we cannot do really anything with that sine x, but tangent x we know is the ratio of the sine over cosine. So we're going to write it as sine x over the cosine x. Okay, I'm not doing anything with the right hand side. All we're working with is like the left hand side here. Let us simplify this further. So it's 1 over cosine x minus, and when I simplify this piece, it will become sine x times sine x, which is simply sine square x, right? Nothing really crazy going on here. And then there's a cosine x in the denominator. Luckily for us, guys, both have the same denominator, right? If they didn't have the same denominator, then we will have to do an extra step to get the same denominator, but they already have the same denominator. When they have the same denominator, we can quickly or easily combine the numerator. So in this case, we can simplify this by just writing the denominator once, cosine x, and then we can combine the numerator, which is 1 minus sine square x. Still working with the left hand side only. Now let us see if we can simplify this further. Guys, 1 minus sine square x, this is the consequence of the basic Pythagorean identity, that sine square x plus cosine square x is 1, And if you are trying to solve for the cosine square x, that will be 1 minus sine square x. So this 1 minus sine square x can be simply replaced by cosine square x, and that comes from the Pythagorean identity. Guys, that is why I said you have to have the formula sheet in front of you. And I would also like go ahead and say that you should try to remember some of the formulas, but it's fine if you don't remember. Just have to have the formula sheet in front of you, and you have to be able to like go back and forth with the formula sheet and know like which formula is where. Okay, so just like go through the formula sheet like few times and see, just read through the formula sheet, I would say maybe once or twice, to see like where is the Pythagorean identity, where is the sum, where is the product, where is the half angle, where is the double angle, so on and so forth. Okay, and then in the denominator I have a cosine x. Now from here you already know what to do. There's a cosine square x here, which simply means there's a cosine x times cosine x, right? And then there's only a cosine x downstairs. Well, what is going to happen to one of the cosines? It will just cross out. So I'm going to cross this out, and what I'm left with is, from here I'm going to take it up here, it's just the cosine x, and that is exactly what the right hand side is. So what can we conclude finally? And we should actually write that final kind of step, which is, it implies that the left hand side, so we got the left hand side, we simplified, we used the identities, and we got it exactly like the right hand side. So finally from this, once we have this, we can justify, which implies, this implies that the left hand side equals to the right hand side, and we are done. Right? That was the goal. We wanted to prove or verify this identity, that this equals to that, and we were able to do it just by working with the left hand side, simplifying, using the identities, using the algebraic techniques, the concepts, the things that we have learned in algebra and pre-calc, and finally we were able to get it equal to the right hand side. That is, guys, number 1. I started with the easier one, and as we go on to the number 2 and up to 7, you will see the challenge level is going to increase, and we're going to try to cover many different types of examples. Okay, so guys, till then, take care. I will see you in the next